All right, slope and rate of change. So we've talked about this in seventh grade. So this, for the most part, should be review. We'll get a little more in depth, but it's stuff we've done before. So let's just take a look at this example they give us. Jerry has two hills near his house that can be chosen from to go sledding. A side view of each hill is given below. So here are the side views of the two hills. Compare the vertical distance, which is here, so remember we call that the rise. We're going to compare that to, well, we're just going to compare those two. So look at the vertical distance for each one. Let me see. Giselle, would you mind moving here next to Yesenia so that we're have pretty much close partnership there? And Gabriel, you can work with Juan and Izzy, and I think we should be good. And then in the back, Kaylee, Ivan, you work with Dayanara. Okay, so talk with each other, compare the vertical distances. I think this one's easy though. What can we say about these two vertical distances? Hey, same. All right, let's look at the horizontal distance, otherwise known as the run. Compare those to each other. Those aren't the same. Which one is longer? Hill A. So let's just say Hill A is 10 yards longer. Mm. Okay, so now let's compare the steepness. Which one is steeper? And this is where I do want you to check in with your table partners and determine which hill is steeper and have a good reason why. Maybe look at some comparisons of numbers. Okay, so I'll give you some time for that. Um, so, did we decide which hill A or hill B? Which one's steeper? Because, well, what makes it steeper? Can we? It has a smaller horizontal distance. It does. It's 20 compared to 30. Uh huh. Okay. Shorter. So because it has a shorter horizontal. I'm going to say compared to hill A. Yeah, and basically that ratio, right? Here it's 20 to 20. 20 yards up compared to 20 yards across, which is 1. Here it's 20 to 30. And what's 20 to 30 reduced down to? 2 over 3. And which number is greater? Which number is bigger, 2/3 or 1? Yeah. For every yard, inch, whatever we're doing, meter, you go up, you go the same across. And here, for every 2, you go 3 across. So you make a little more progress. Okay, so let's talk about slope again. Okay, on graphs, a linear relationship slope describes the steepness of a line. Slope is the ratio of the vertical change compared to the horizontal change. So vertical change compared to the horizontal. And what's the common term? Remember, we used it a lot last year? Rise over run. That's a quick, convenient way when we have graphs to look at to determine the slope. Slope is equal to the rate of change of the graph. And every graph has a rate of change. Now, we're going to start with lines because they're the easiest to determine the rate of change. But one of the big things you do in calculus, for example, what almost the cornerstone is, let's say you have a graph of a curve. Okay? One of the things you determine in calculus is, take this point, for example. What's the steepness? What's the slope at this point? Well, it's going to be there, right? And it's going to be different than, say, the steepness here at this point. Because this is going to be there. And it's constantly changing when it's not a straight line. When it's a straight line like these, the slope is always the same number. You could look at this point, the slope is the same as if you look at that point, or as if you look at that point. It's always the same. It's a constant slope. But when you have curves, it's curvy by nature. And so the slope is going to be changing. And that's one of the major things, believe it or not, that calculus is all about. So the seeds we're planting now are going to continue into higher level math. Okay, so let's review the 4 types of slope. We did this last year. So if our slope is going uphill, remember what we called the slope going uphill left to right? Positive. How about left to right going downhill? Negative. Anyone recall what we call this slope when it's horizontal? Zero. It's a zero slope, yeah. So anytime we have a horizontal line, the slope is 0. Okay. How about when it's a vertical line, straight up and down? Undefined. Here's the reason it's undefined. So if we do like calculations with rise over run, we're going to end up with positive numbers for when it's going uphill. When we do calculations, rise over run for downhill lines, it's going to be negative. So it's going from positive to negative, but in between, it's going to be flat. So it's positive, 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 but smaller number, down to 0, then negative. And then when it's straight up or down, it's technically infinite. but we just usually say undefined. Okay? The rise is infinite, right? You're just going up, up, up. Um, but we'll just call it undefined because technically you're dividing by 0, which we'll see. And yeah, that's going to be undefined. All right, let's get to some calculating. We're going to find the slope of each of these by comparing the ratio of the rise over run. So for all of these, rise over run. And we'll go quickly because we did do this last year. So slope is equal to rise over run. So my recommendation, just like I did last year, when you have your 2 points, like here they gave us 2 points for number 1, start with the lower, the one that's closest to the left. This is your starting point, if you can. And we want to rise up or down, then run right or left. You'll always be running to the right. So we're going to start here. And look at your scale. We're counting by ones on each one. So this is easy. So let's start here and do a rise of 1, 2, 3. This is plus 3. And what's our run? Oops. It's 2. Let's start over. Our rise is 2, and our run is 3. So we would write this as the slope of rise 2, run 3. For every 2 we go up, we go 3 across. For every 2, we go 3 across. That's the steepness. Okay? So help me out. What do I have to do to find the slope for our second graph? I don't have points. What do I do? Create your own. So the thing is, you want to find points like this one here at -4, where it's what we call an integral point, where the coordinates are integers. You don't want to pick points in between. Like I would not pick the point at -2 for x because it's in between. So here's one point. Where's another good point? 14? Oh, okay. Here. So that's at 0. At 0, it's 14. That's another good point. Now we could have also picked 8 at 8. At 12 here. It's a little off. This would have been another good point, apparently. But let's pick those because those are good. At -4 and 0. So this time, if we're picking points furthest to the left, we're going to start here. We're going to go down. How many did I go down? 1 step, but is that just, what are we counting by though? 2. So this is down 2. We're going down 2 units because we're going from 14 down to, from 16 down to 14. Are we also counting by 2's on the x-axis? Yeah. So if I go 2 steps over, how much is that? 4. And that's going to the right. So would that be positive or negative? Positive. Yeah. So remember, going up is positive, down is negative for the rise. To the right is positive, to the left is negative for the run. So this is plus 4. So this is -2 over 4, which is the same as -1/2. All right. For the last one, we have a vertical line. So what is that? 0. Let's go back to our, it's vertical. It's technically undefined. Here's why it's undefined. Pick any 2 points. I'll pick those two. And our rise is -5 if I decide to do that. Right? What's my run? Nothing, 0. So this would be -5 over 0. And you're saying, well, you may be saying, well, that's no big deal. It's not 0, by the way. Let me see here. -5 divided by 0. I get a divide by 0 error. That's why it's undefined. You cannot divide by 0. So the true answer is undefined because you divide by 0. Okay. We end up dividing by 0 whenever we try to find the slope for a vertical line. And you can't do that. It's a big no-no in math. Okay. We'll move over to the other side. Next page. So we're going to do some application questions. So this is where you will be working with your table partners. Ready? Okay. So I'd like you to use your knowledge of slope and rate of change to answer these questions. Let's start with 4 and 5. So let's read over 4 and 5. Number 4, Clark loads boxes of paper on a pallet before shipping them. The graph shows the linear relationship between the number of boxes of copy paper and the weight. So this is the number of boxes. The more boxes he loads, the weight increases, obviously. Okay. Find the rate of change of the pallet weight with respect to the number of boxes. So this means we have units. So we have to incorporate the units in our answer. Look at the units we're doing for the x-axis. Look at the units we're doing for the weight. Okay. And then number 5. Look at number 5, read it through, and then incorporate the units. We're doing customers versus dollars. Okay, so I'll give you some time to talk it through and find some answers. Make sure you have units incorporated in your answers. So I was doing a little work on my own. So for number 4, it was 20 pounds for every 4 boxes. I can simplify that to what? 5 pounds for every 1 box. So it's 5 pounds per box. For Lainey, it says set up a lemonade stand. The graph shows the amount of money in her cashier register with respect to the number of customers Lainey has served. Find the rate of change. So I didn't pick the best points, but maybe I get the same answers all of you did. My rise is $6 for every how many customers? 8? Oh, this one? Yeah, that would have been better, right? But maybe if you missed it, or that one. Okay, that one, I'm sorry, yes. That would have been the better choice. But even if you don't pick the optimal points, if I reduce this, this becomes what? 3/4 dollars per customer. Okay, so if it's 3/4 of a dollar per customer, how much is each lemonade? What's 3/4 of a dollar? 75 cents. So this just told me she's selling these for 75 cents per person. Okay. So you could do, actually, here it is probably better to write it as 0.75 dollars, which is 75 cents. per customer. Okay. All right. So move on to 6, 7, and 8. I'll give you the challenge of number 8. So try those. 7. Guys, let's look at number 6. A cold front hit Milwaukee, Wisconsin, and the graph shows the outside temperature with respect to the time passed in hours. Find the average rate of change of the temperature between 3 and 6 hours. Okay, so let's just see how it's dropping. Since it's a linear, it's going to be the same each way. So my rise was negative. The temperature dropped by how much? I went from 15 to 5. How much did it go down? Negative 10. Over how many hours? 3. Okay, so it's down 10 degrees Fahrenheit every 3 hours. Okay. Jacob passes. Jacob hopes to read at least 4 pages every 5 minutes in his sci-fi book. The graph shows the rate at which he reads. Did Jacob meet his goal? Explain. Okay, let's figure out how he did. I picked out 2 points. And it looks like he read 9 pages over 15 hours. Or 15 minutes. Nine pages every 15 minutes. What rate is that? Okay, 9 over 15. And then I could reduce that by 3. 3 over 5. All right. So is that better than 4 over 4 every 5? Or worse? Did he meet his goal? No. So Jacob did not meet his goal. So Jacob read 4 pages or 3 pages every 5 minutes, which is less than 4 every 5. Something like that. Okay. Now for the last one, I noticed you guys were trying different strategies. This is what I was thinking. $11 every 3 minutes, 3 weeks. I turned them into decimals because it's easier to think of money that way. I divided and thought of decimals. So that's $3.67 every week. $9 every 2 weeks is $4.50 a week. And spending means you're losing, that's negative $7 every week. So that might help us figure out which one is which. Which line corresponds to the first one? $3.67 per week. C. Yeah. So B would be $9 every 2 weeks. And obviously the one that's negative would be A. Okay. All right. So the assignment's going to be on delta.